In this video, we're going to show how to handle threads within the Java technology. We're going to be using the Itla Racer application that we have done in order to show you the threads capabilities in Java. You can clone this repository from the link that you are seeing right now, and this URL is also available in this video description. Alright, so let's open this project in our preferred IDE. In this case, I'm using Eclipse. Alright, so let's open the project and let's go from the beginning. The Itla Racer class is the one that has the main method. The main method, first it has an instantiation of the class track. Track is the visual track where we can see, if you go to this class declaration, that is a class that extends from the JFrame class. So we can see that it has an array list as an argument, as an attribute, which stores all the vehicles that are going to run in our track, in our race. So let's take a look at the constructor. Here in the first line, I'm calling the constructor of the superclass, in this case the JFrame class. And I'm calling the constructor that receives a string as parameter. And that constructor from the JFrame class that receives a string as parameter, it takes that string and makes the title of the window. So in this line, the number 14, I'm calling the sextendedState method that makes our window maximized as default state. So here in the next line, I'm just saying that every time that the user clicks on the close button of my window, it will close the entire application. So finally, I am instantiating the ArrayList class and I'm storing that instance in my vehicle attribute. The next method is the add method, which is a simple one. I'm just receiving a vehicle, and that vehicle that I'm receiving as parameter, I'm adding to my ArrayList attribute. So finally, I have my start method that, as its name suggests, it starts the race. So the first thing that I want to do is to set layout for this JFrame. The layout that I picked for this one was the grid layout, which is the layout that allows me to divide the screen in a set of rows and columns. In this case, I'm setting the number of rows as the amount of vehicles that I have in the vehicles array list. And then I will always have only one column in this grid. Then I am creating a track length reference, which by default is null. I'm creating this outside of the for each, because if I create the declaration of that variable inside of the for each, it could translate into a memory distress. It will cause a memory to use a huge amount of it, and I don't want that. I don't want an overhead of memory management. Alright, so here I'm instantiating the track lane class. Track lane, if we see the code, is a simple class that extends from the JPanel. JPanel is a simple container of the swing graphic library. So what I'm doing here is extending JPanel and overriding the paint component method. So what we are doing here is simply creating a subset of JPanel that draws a background image of a track lane. We can open that image and you can see that it looks like a lane, like from street, in this case from our racetrack. Alright, so I'm just creating an instance of the image icon class, and then I'm saying that this container is not opaque, which means that the color, background color, is not going to cover my image, so my image is going to be visible. And then using the graphic parameter that I have received from the paint component, I'm going to call its drawImage method, which receives 4 parameters. The first one gets the image reference, the image instance that is surrounded here in the image icon object. Then the following 2 next parameters represent the image position in X and Y. Well, obviously horizontal position and then the vertical position. As you know, here in Java, as many other graphical systems coordinates, the origin, the point the origin 0, 0 is here at the superior part, top left part, no? So that's exactly what I'm doing here. I'm saying that the image that is going to be drawn is going to be drawn in the top left corner of the window. And then the 4th parameter that we are sending here, we are sending null, it's an image observer. It means that every time that there's a change in my image, it's going to call that observer. If you want to know more about the observer design pattern, you can visit my webpage www.redalto.org, and you're going to see a video tutorial about that design pattern. Finally, we're just saying here that we are going to call the paint component method that it is contained in my superclass. In this case, the paint component method located in the JPanel class. All right, so let's continue here in our track class. So here we know that lane is a container because it's an instance from the track lane class, and track lane class is a subclass of the JPanel. Then to this container, I'm going to add the JLabel that represents the image of each vehicle. If we take a quick look to our vehicle class, we can see that one of its attributes is in JLabel, which is called label. So what we are doing here is that we are painting each car by representing them as JLabels. As you may know, the JLabel class is a class that represents a visual label. It is supposed to be used for creating text, but you can also add some background image to the labels. So that's exactly what we're doing here. We're taking that label, we're putting a background image to it, and then we are painting it. In this case, the background image we're putting to these JLabels are the vehicle's images. So if we want to paint those cars in a visual manner, we just have to paint that JLabel. We just have to add that label to a container, which is exactly what we're doing here. We are adding the label to the lane panel, and then the lane panel, we are adding it to our frame here. So when we have all cars set in place, we have all our lanes, we have all our graphic components, that is when I'm making my window visible. You have to be aware of that. If you're using the swing library, you have to be aware that you have to make the window visible just after you have all your visual elements in place. Because if you don't do that, it could get messy. Like, for instance, you may have a button that shows sometimes and sometimes it doesn't, just because of the thread are playing you some trick replay right now. Because the window, the J frame, the string J frame, is painted within another thread, which is separated with the main thread. So we have to make sure, the bottom line is you have to make sure that you have added all the visual elements to your J frame before calling the set visible, which is exactly what we have done here. We have put everything on place, then we call set true, set visible true. All right, so after our window is true, we have here another for each. We are going vehicle per vehicle, each by one, and then what we are doing here is that we are getting them some starting position. So the starting location will be the X attribute from the vehicle class, which have been set to 0 by default. If you can see here in the car constructor, we can verify that we have put the X variable to 0, since those variables, the X attribute for instance, was inherited from the vehicle class. And as you may know, if you have an integer attribute, it will automatically initialize to 0. So that's why car has an X value of 0 as default value. So we're going to put the X value, we're going to put the same one that it already has, and then I'm going to finally start the thread. Since vehicle is an instance of the car class, and car class extends from vehicle, which extends from thread, that makes each car a thread. So since each car extends from thread, we can override the run method, and this run method is going to run in another thread. So each thread, what it's going to do is to move our car in a different thread. So I'm going to have one thread for each car that I have in my track. So inside this run method that's going to be run in another thread, what I'm doing here is a for cycle. This for is going to be run 1,000 times. So each time it's going to set the new X position by saying that the new X value is equals to the actual value of X plus the velocity. Obviously, the higher the number of the velocity is, pues then it's going to be a larger movement. And then we're going to set the location to that label. So the X position is going to be the value that we have just set, and the X value is not changing. We're just putting there the actual X value that it currently has. And then I'm going to call the static method sleep, which is going to put our thread to sleep. That method, sleep, receives an integer that represents the amount of milliseconds that I want my thread to sleep. So in this case, I'm dividing 1,000 by the velocity. It is obviously that the higher the velocity is, then the shorter is the sleep time. So we just went to the code. It's a really short and simple code. I think we are ready to start engines. Yeah, so here to finalize here, you can see that the first car has a velocity of 5, the second has a velocity of 6, and the third one has a velocity of 4. Then after setting the velocity, I added them to the array list, and finally I'm starting the race. So as you may notice here, the second car has a highest velocity. So that means that that's the one that's going to win the race. So let's start this. I'm going to right click to the Untitled Racer class. I'm going to click on Run As and then Java application. So let me resize the window so you can very appreciate it. So you can see here we have 3 cars are struggling to win the first place, but as I mentioned, the second car is going to win because it's the one that has the highest velocity. So I just made that simple example so you can play around with threads in a graphical way, because I know that many of you guys that are learning the Java technology that you're starting with, it's kind of hard to visualize threads, since you may be always using the console text applications to test these kind of things. So this code, it's available. I made it available on GitHub, as I previously mentioned. You can clone it. The URL is available here from the description from this video. So I hope you have enjoyed this video. If you want to see more videos of this kind, you can visit our web page, which is www.redalto.org. Thanks for watching.